Hello community, so great that you are back. Let's talk about the future of GPT, because it is not about intelligence. Let's start, and of course, welcome to Discover AI, your channel here where we have a look at the latest AI research. Now, in my latest videos, we realized that generative here pre-trained transformer systems, even combined with knowledge graph, are not reliable if you really want to do some reasoning task in medicine or in finance. And since we discovered here a much more professional and trustworthy solution, see my last video here on graph merge system here in this video, where we have a beautiful new model here, an 80 million free parameter model from Princeton that beats here the GPT-5 thinking model. What is now the future of the GPT models? Where can we apply now this outdated technology of GPT, let's say 6? Let's have a look, because there are some indications that I want to share with you. Now, of course, if you say, hey, what are you talking about? Just ask your ChatGPT, hey, why does GPT struggles with pure logic analysis? It has a lack of a determinism, has no formal symbolic memory, GPT has only surface level pattern recognition, is inconsistent about long logical chains, has no formal proof verification. And you got a list. This is even what ChatGPT tells you, and you don't even have to watch any of my other videos to immediately see this is not the way forward. Now, interesting, just yesterday for me, we have here a post by Sam Altman. And it says, in a few weeks, we plan to put out a new version of ChatGPT that allows people to have a personality, which is a little bit strange that you have a new version of ChatGPT that allows people to have a personality. And even ChatGPT agrees and says, hey, this is wrong, because people currently don't have personalities and ChatGPT will grant them this ability. Or is there something massively wrong in the formulation of this sentence? But let's have a look at GPT's multi-trillion-dollar growth path. And it is not an intelligence. So you might ask, hey, what is it all about? Welcome to the 4 new research papers we have a look at. Now, as you see here, recording this on the 17th here of October 2025, just yesterday, October 15, those 3 papers and 1 day before, those were published. Have a look. We have here Tianjin University in China, University in Exeter in the UK, UC Berkeley and Princeton University. We have Tsinghua University in Beijing, and we have Google DeepMind in the US, in Canada, in France, and even my research institutes in Switzerland. And they all have here some beautiful, interesting ideas about the future of GPT systems. And I selected those 4 papers for you just to give you an idea what currently is the research topic. Let's jump in with the first paper. It is about the personalization of emotions via a GPT system. And here we have it. Tianjin University and University of Exeter in the UK. Emotional cognitive modeling framework with desire-driven objective optimization for a large language model empowered agents. Now, this is quite a mouthful. You might say, what the hell is going on? I don't need this, no? I just need my coding LLMs here to write code or just to do my homework. What the hell is happening? Why are researchers doing this, no? And if you start to read, you see it introduces here new mechanisms for our AI agents with the LLM at the core to make decisions, that are not just rational, not logic, not a causal reasoning, but emotionally congruent and human-like. And you might say, this is interesting. So, why? Why is it happening right now? What is here the purpose? And OpenAI plans to hit here 1 billion ChatGPT users by the end of this year, by the end of 2025. And this is amazing. What a success for a startup company. But you know what? Only a tiny portion of those people will use GPT systems for coding or for logic or for finance or for theoretical physics. Now, I've shown you here in this video here where we talked about neurosymbolic 80 million AI from Princeton beats GPT. We don't need, for the future of AI, for the logic and causal reasoning part, we don't need here the decoder part of a transformer architecture that is normally called a GPT system with a next token probability prediction. So what is now the future of GPT? Is there any future? If we have an IPO from OpenAI, should you invest in this? Well, let's have a look at research. I can only give you the research paper. You know what? I think emotional patterns, oh, there's a T missing. Emotional patterns are not necessarily to be logic, no? And this paper now from China constructs now an emotional cognition framework incorporating desire generation and objective management designed to achieve an emotional alignment between an LLM-based, a GRP-based agent and humans. Modeling here the complete decision-making process of LLM-based agents, GPT-based agents, encompassing state evolution, desire generation, objective optimization, decision generation, and action execution. And at this very particular moment in time, I said, I don't understand anything. What is this? And then I rewrote it so I can understand it. Hey, listen, this is now an AI that helps you to buy a product at 2 o'clock, 2 a.m. in the night because I am lonely, maybe I was not successful, I want somehow to compensate, and now I have a GPT system that recommends now a very particular product, whatever it is. AI now generates a desire in my emotional construct, maybe my brain, maybe my heart, and therefore I need to buy this commercial product as offered by an AI right now. So you know what we are talking about? We are talking about emotional decisions that are AI-induced human behavior. And you might say, oh, wow, because up until now, we only had more or less Google that is financing itself here by ads. No? But imagine if we could have this with AI. And you might say, yeah, but listen, this is not concerning me. No? Because if, let's say, we have a total addressable market and a user group here of 1 billion, maybe GPT wants to, or OpenAI wants to grow to 3 billion user, but let's stick with 1 billion user. How many people will use here a GPT system as a coding system? And currently, I think it's called GPT-5 Codex. I don't know what it is called when you see these videos, but you get the idea. Look, it's just one little tiny segment. But let's analyze here the complete growth trajectory for the company OpenAI and include now all non-coding tasks here in the white array. Do you see what opportunity GPT or OpenAI has, even if it's just focusing on emotional decisions like, hey, I want to buy here or want to convince a human to buy a product here at 2 a.m. in the middle of the night. AI-induced behavior. And you know what? You don't need to be logic. You don't have to have intelligence. You just have to have a certain particular behavior. So behavioral patterns in humans are not logic or string and causal. So, hey, we can use GPT for those tasks. Behavior patterns of humans can be chaotic, irregular, and say, hey, this is a bullseye. Yeah, beautiful. So we can use GPT systems for this. And behavior patterns are open and easy to learn for any pattern matching machine like the decoder part of a transformer architecture, like a GPT system. Now, what a coincidence that we have here the latest post here by Sam talking about personalities. And let's have a look. The first paper is about GPT for human desire optimization. And you would say, but this has nothing to do with science. Listen, buddy, I'm interested here in science. What are you talking? What are those researchers doing? A human desire optimization? Well, you're going to be surprised. As I told you, this is here the official paper. So what are they doing? They say, you know what? We have a pattern machine. So let's amazingly have the idea. We have a causal chain of an external, of an internal state change here of our agent that has an effect here on human emotions that can generate desire in a human being that will have here a mathematical objective function that we have to optimize. And then our GPT system can execute specific action in the interaction with the human so we can induce a desire in a human being. And you say, you know, we just follow the old playbook. An agent state at a particular time t is a composite vector here in a mathematical vector space. So I do have here a state vector here at a particular time, and I have here income elements like the income, the health, the social rank, and the emotional state. I don't want to talk about that from social media. You have, if you are Meta, let's say, a very clear idea about the income of your user that are using your platform, or the health status, or the social rank, because you see the social networks. But let's focus here only now for this video here on the emotional state. Now, emotional vectors are not arbitrarily assigned to you as a person, to you as an individual by the CI. It is calculated using your mathematical model. I'm not sure if this is the right model, but hey, I'm just following here the scientific publication, where each dimension is a function of the change in the state variables. Like we talked about, income, health, your social network, how many people follow you, what people exactly do follow you in Facebook, in Meta, in whatever model you use for social media. And you see suddenly, if you can, as an AI, trigger an emotional decision by a human to buy a product in the middle of the night, you need to have some background information, and let's see if an AI can achieve this. So the agent's core desire is now, let's say, prioritize the wealth or the wealth aggregation versus a health statement. This can be a stable vector if you think about here as a Markov decision process. And this vector is only updated when a significant emotional event occurs. Like you have a sharp transition from happy to anxious in the human phase, which then will trigger a re-evaluation of the priorities also in our agent. So the updated desire reshapes now the agent's reward function. So we have now we only have one training ability. This is reinforcement learning by verifiable rewards. So our reward itself will now be modified. Yeah? This reward function biases here the LLM generative process using now our classical reinforcement learning by human feedback style policy, PPO, GRPO, DPO, DAPO, whatever you have. And this will lead now our LLM to generate specific actions in the interaction with this single human user that will align with the current emotion-driven objective that this human person is currently in. Here you have from the authors here our emotional cognitive modeling framework for LLM GPT-based agents. So you observe via social media here the state that this person is in. We have all the environmental information. You have the self-information. You have analyzed the complete social network this person is on all the different platforms. And then you go to a desire-driven objective optimization via mathematical status. But of course, you need all the real-world data. Then you can calculate here the state depending on all the different parameters that you can simply calculate. This is no problem. And then we just have here our classical AI training where you have a particular objective that you want to optimize here, your goal that you want to objective. And this is simply the reward function here from reinforcement learning. This is just familiar, no problem, nothing new. And then you generate actions and decision by the AI to achieve here single behavior or sequential behavior in a chain, or some composite behaviors if you have maybe a longer conversation, or maybe this conversation is going over days with the human user. And I give us here a very vanilla example. So I imagine a delivery agent has a wealth desire. No? It accepts manual order, increasing its income, but decreases, of course, its health. No? There's a lot of stress in this job. And now the sharp drop in the health triggers maybe an emotion of surprise or anxiety. No? And this emotional shock updates now the desire to health. And this is now calculated as a mathematical model. And now the reward function that detects and analyzes here this behavior heavily weights now a more positive delta here on health, the health factor in this equation. So the agent's policy, the strategy how the agent will behave in the future, will now favor maybe rejecting here some real distant orders and taking more breaks, even at the cost here of a little bit of a reduction in the income. And you know, reading this paper, I thought it feels strange. Why would anybody do this? And then I had a very stupid question from my side. You know, I'm not the intelligent one. And I said, is there a possibility that human interaction with GPT systems are exerting here a subconscious influence on the human behavior and on the human belief systems? Is this possible? Are we being subtly influenced by our AI systems, our preferred AI systems, in ways we are not consciously aware of? Is this what this AI research paper wants to show us? What about the second paper? The personalization of empowerment, of human empowerment. And I thought, hey, this makes sense, no? This, finally, it's not that AI is doing all the job for us, but it gives you human empowerment. Feels good. By GPT. And I said, wait a minute, let's have a closer look. Now imagine an LLM, a GPT system by OpenAI, or any other global corporation that you love and you pay for your AI systems. You know those? They know your professional qualification in writing code, as a coder, whatever you are. But because there's now this new idea to make a coding LLM or any advanced code AI stop at certain inflection points and give the control back to the human, you know what this opens up? Now this opens up some interesting element. You have a framing from quite different points of view. Let's have a closer look at this. Now, either way you see it, hey, this empowers now the human coder. Eh? Whenever there's some critical code sequence or some decision to be made, how do I want to implement this mathematical algorithm here in a particular way? Or how do I want that my app analyzes certain whatever from a human? Now the human can decide what to do and code here the most important sequences of code. Or you can say, wait a minute. With this methodology, all the, let's say, global corporations that are, of course, there to help you in your professional qualification, they can now evaluate the innovative code solution of this particular human, since this LLM GPT system will evaluate and store all of your genius solution, all of your solution and all of your failures. So those systems have, if you pay for them and you have given them your identity and all your credential, they have quite a good idea about your professional qualification. And let's say we stay here in a simple example as a coder. Now let's say, but wait a minute, what is now exactly the problem we are trying to face now in this second research paper? Now the authors tell us, hey, the main frustration with tools like a GitHub Copilot isn't that they are unhelpful, but they are often overconfidently wrong. Well, yes, of course. It's a decoder GPT. Those systems, the GPT, generate a large block of code that looks absolutely plausible, but you know what? Maybe it will contain a subtle but incorrect assumption. And we as user, and I hope you are much better coder than I am, you will spend here quite some time debugging here the AI helpful suggestion than it would take to write the code themselves. Now, this new methodology, in this new paper, they call the Empower method, directly targets now this, let's call it a failure mode. No? And now the AI learns to stop before making any critical, assumption-laden decision. This AI will now avoid the most frustrating and costly type of any error, because the AI will simply say, you know what? We are coming now to a critical inflection point, and I as an AI will stop and I will hand over the control to the human, and now the human can write the code. Beautiful new paper, October 15, UC Berkeley and Princeton University. Look at those beautiful people training now LLM GPT's agents to empower the humans. And I thought, this is a gorgeous title, no? Finally, a new method for fine-tuning our GPTs to better assist the humans and not do the job for the humans. No, they are now helpful assistants to the human jobs. Great, I have to have a look at this study. And I read this study. And you know what? There's a surprise in this study. Now, of course, so assistive agents here should not take actions on behalf of a human and do the homework of humans or do the complete coding exercise for human or do the professional job of a human. The human would not learn in this way. So they now say, you know what? We think that the AI should step out of the way and cede control over to the human whenever there are important decisions to be made. And they just go with coding as an example, but please take your domain knowledge, what that you are working with. And they said, you know what is the challenge when we use here those AI coding agents? The code suggestions start out helpful, But then, if they implement now complete passages, sometimes they implement the wrong idea, or in a way that we don't want this, or simply wrong functions, or whatever is wrong on GitHub. So often an assistant will suggest here a large block of code and the users accept it, and then they have to spend time and time again fixing here a single part somewhere that it went wrong, like an incorrect assumption that the AI did when writing this code, or choosing here the wrong GitHub repo. So the authors asked now, hey, can we develop coding assistants, AI structures, GPT systems that still produce helpful generation, but also know when to stop? AI agents that stop their code generation at critical junctures. When there is a decision to be made, hey, how do we proceed with the next code segment? What a beautiful idea. What a helpful idea to empower humans. Yeah, but you might ask, hey, how does an AI know when it is time to pass over the control because the code gets so complex that now the human should do the hard work? Yeah? The LLM will automatically assess the usefulness of its actions by estimating whether they enable a human to solve more tasks more quickly. No debugging. The human is there at the right time, at the right piece, exactly, and writes the critical code sequence. And then, for the easy stuff, the AI just continues to write the secondary code level. So, in coding context, empowerment might correspond to implementing a helper function, writing boilerplate or writing up just some secondary lines of code. Great. And then I move to an example where you have two agents. You have a coding assistant, an AI, and a human agent. And I love that suddenly humans also are agents and at the same level like AI systems. It requires a more nuanced definition, they say, of empowerment. What exactly is empowerment so we can calculate it with some mathematical formulas for our AI system to be effective in this? And the authors tell us, hey, we aim to empower the human agent, enabling here the human user action to exert a larger influence over future outcomes. This is a very intelligent approach. And I was amazed by this. And it took me some time, because I'm a simple man, to find out where does it come from. But before this, and the authors tell us, hey, our results now demonstrate that our LLMs, our GPT as coding assistants, can be trained without receiving any feedback or interaction from humans. And you know that internally I smile. So I say, you want to empower humans, but you don't have feedback or interaction with humans? Oh, this is going to be great. By reasoning about how their actions might enable humans to complete more tasks more quickly. Now, this is interesting. And guess what was here the theory that they used here? For the training, we always use reinforcement learning by verifiable feedback. And any problem currently in AI is that we start with a Markov decision process or the partially observable Markov decision process. And guess what? The authors stick with this proven methodology. And it's a good choice. Yeah, the state in the program text at a given time step in each state, the LLM agent suggests now a piece of text to append to the conversation. And the human agent now says, I accept this, or I reject this, or hey, we are finished. So a very simple Markov decision process. But let's come back to this idea of empowerment. The authors tell us, hey, we got the ideas from a paper from 2005. It's not anymore an ArXiv, so you have to go there from a university or whatever this is to find the original paper. And they are here from School of Computer Science, University of Hertfordshire, a college laying in Hatfield, Herts in the United Kingdom. This is an idea I have never heard of. A universal agent-centric measure of control from 2005? They were talking about agents? Holy smoke. And they cite, inspired by examples here from the animal kingdom, not the United Kingdom, the animal kingdom, the social sciences and games, we propose empowerment, a universal function defined as an information theoretic capacity of an agent's actuation channel. So they come from information theoretical approaches, of course, beautiful mathematics, and they say, yeah, we have a local and universal utility function and beautiful, and they give you here the idea of their communication problem. And they talk here about information that can be expressed as a function of the probability distribution. Imagine in 2005, over the transmitted signal and the distribution characteristic on the channel. And then you have here the channel capacity and the transmitted signal. The channel capacity can be calculated here based on an information theoretical approach. And then they came here to a mathematical definition of empowerment as the channel capacity of the agent's actuation channel terminating at the sensor. What a beautiful idea. You have to read the paper to really understand what the authors of the paper of just 2 days ago implemented. They took exactly this idea and they implemented it now in an agentic AI system. And of course, it is about information. It is about sharing information. What a beautiful idea. You have to know your history. Okay, coming back. So what is it now? Now, in the latest study here, October 15, empowerment is a useful objective. We are back in reinforcement learning for assistance because it helps people quickly reach states where they have many choices. So it takes broadly useful actions that are helpful to the most people. Now, you know that in general, all GPT systems are trained to be helpful. So we come now to a redefinition of the helpfulness. And I told you helpful means in most cases, just provide an answer. And at the beginning it was, give it whatever you know. It is not okay to say, hey, I don't know, I'm an AI system and I can't solve this. You know, this is not good for marketing. So helpfulness was complete the task and provide an answer. But now this is not what is the task. Now that is the task, stop whenever you reach here a level of empowerment we can calculate with a mathematical formula. And they say this leads to a more natural type of AI assistance in coding that does not make assumptions about the human goal. So think about this. You have an AI system that doesn't maybe know you, in your coding style or whatever, and it doesn't make any assumption what you as a human want to achieve. What is your personal goal writing this code? It just says, you know, I have a general mathematical formula that I can calculate the inflection points in my coding solution. And therefore, with this, I can redefine helpfulness as a maximization of the human's ability to make meaningful choices. Now, you are gonna smile if I tell you the solution. Huh? The new empowerment, or empower algorithm as it's called, trains now a GPT coding assistant to complete predictable text segments with a low entropy, and to stop precisely at the point where the creative input, a high entropy token, is required. I have multiple videos on this channel how to calculate here high entropy and low entropy token calculations. What a beautiful idea. And now our LLMs, our GPT, are now an estimator. The entropy is, of course, only estimated. Of course, we have a GPT system. We don't have here a factual, really 100% correct calculation. It is estimated using here a pre-trained LLM. So another LLM tells us, hey, this I think is an estimated solution of your entropy function as a proxy for the human response distribution. So all depends now on the second pre-trained LLM that it can really mimic your human response. And now you understand why they don't need any human feedback. We just have another AI system that pretends to be you. So here you have it, very simple. So what is it? This coding agent, this coding GPT system says, you know what? I'll handle all the boring stuff, the boring syntax and the boring structure that a programmer would have to write normally, you know? But as soon as we reach a point where the unique insight of a human developer is needed to make a very specific decision for their task, to make a key decision, I as an AI will stop writing code for the human, come on, and let the human write the code. And then I can assess it and I can say, okay, the human is good enough or not good enough, or the human doesn't even understand what code I'm writing here as an AI system. What a beautiful insight in the professional capabilities of humans. And I give you here exactly here the assistant results here with a Llama 3 that is now the human and models here the human. And they have here as decoding a Llama 3.18b or a Xuwen 3.8b or a Xuwen 3.14b. And you see, oh, those are for all the benchmark here, exactly here, the performance. So a very easy idea with an absolute fascinating implementation also on a mathematical level. Your coding assistant generates code as long as the path forward is predictable and common. It's boilerplate. It has here no problems inside. And the very moment the code would require here more meaningful and more creative was a not obvious decision that I already implemented in 10,000 GitHub repos in the absolute exact same code sequence. At this point, where very many different valid paths could be taken and suddenly open up like a spectrum in front of you, the AI stops and handles the control back to the human and says, hey human, you decide where we will go next. I just love it that they, how to say this, they substitute the human feedback by an AI feedback. I mean, nothing against the Gemma 327b. But can any Gemma 327b mimic my behavior as a human? And to conduct this with real human programmers would be astronomically expensive and would take months to coordinate. No? And with a Gemma 327b, you can run this here overnight on a single GPU cluster. No? So you see exactly how we optimize our current AI systems today. Money. Now let's be clear. This model isn't running here an entropy check live as it generates token and declines or decides here when to stop here the sequence. No? Those principles are used during the training phase to create here this data set. Now this is interesting. Now maybe you are missing out here on the point of inference evaluation and maybe have a basic entropy check also at certain steps during the inference run, because otherwise you rely completely on pre-trained data sets. And maybe you have not found this particular problem in your pre-training data sets, no? However, you just have to generate here the data set, especially fine-tuned here on thousands and thousands of examples here of prompt and boilerplate completion. So what could go wrong here if you have a GPT system, no? And you just hope that this GPT learns the behavior stopping at the right moment, and it internalizes here now the pattern of when to be brief and when to be silent. What a beautiful implementation. So you see, those are now the first two papers here, October 15, and you see where researchers understand where to use GPT systems. An emotional cognitive modeling, and what I love, the idea to empower humans in their work. Not to dominate or substitute humans, empower humans. And I think they found an absolute fascinating idea. Also, if you would ask a normal person on the street, hey, can you give me a mathematical definition of empowerment in the information theoretical approach? Maybe it is not so transparent, and therefore I've chosen to present you this particular study. But of course, now the other two papers are even more interesting, even more fascinating, because now we will go to the personalization of the learning experience of a human from cradle to grave. Let's have a look at this. Oh, okay, I see the video is already too long, so end of part 1. I hope you subscribe, maybe you join my channel, and I hope to see you in part 2.